g of x equals 1/2 x minus 2, yes? So right here, we're going to write that function. G of x equals 1/2 x minus 2, correct? Everybody good? All right. Now, compare what we just wrote to what I have written here. Do they look the same? They totally do, don't they? Because that is an output, that is an output, yes? That is a coefficient, that is a coefficient, yeah? That is an x or an input, that is an x or an input, and that is a constant, and that is a constant. Does everybody understand that? Yeah? Okay. What do you know about this? What did we discover when we were just working with it? What's the only things we've done for it? We did an x-intercept, which we got to be what? 4, 0. Yeah? Right? And we did a y-intercept, which we got to be what?
0, -2.
0, -2. Now, please look closely at what we have done. What do you notice about everything I have highlighted in purple?
It's the constant.
It's the constant, right? The constant here was b, and it was the y-intercept, correct? So what does that tell you if I have a function written like this, or an equation written like this? What does that tell you about whatever that constant is? It's always going to be the y-intercept. So that is the y-intercept. When, and only when y, or our output, because it's not always y, when our output is isolated. Okay? Then that's the y-intercept. Is everybody good with that? Everybody's okay? All right. Now what else in there do you already understand? We've explained the b, what it is. What else in this function do you guys already get from the 9th grade? It's green and it's yellow.
Ooh. X and Y.
X and Y. You all can deal with X's and Y's, yes? Where do I find X's and Y's that I could put into this equation if I wanted to? Where in math do X's and Y's live together?
A graph.
On a graph. Excellent. Good. So we all know what the X's and Y's are. So what's the only thing left up there that I have yet to explain to you?
The coefficient.
The letter M, the coefficient. Okay? M is slope. Now we have encountered slope already. In English, what does slope mean?
Solve it.
What?
No.
Toby. Okay, what if I'm at the bottom of it? Then the line's going up. So let's change our definition slightly. Jeswin. Steepness. There we go. Slope is steepness. If I am going to have a slope, what must occur? What two things must change in order to get a slope? Supreet. Yeah, it's how we get a linear relation, isn't it? I have to change my y value, either up or down, and change my x value, either left or right. Or you're not going to get a slope, are you? Here's what I mean. There's a point on the graph. Does that point have a slope? No, because it's not a line. If I want there to be a slope, what must I do to put the next point in? I have to add some y and some x, or subtract some y and subtract some x, don't I? If I add y and I add x, I end up over here, don't I? Does that give me a slope? That's what slope is. It is a measurement of steepness. Have we encountered that in our math class this year?
Yes.
Where did slope come into play? On the graph of a distance time situation, yes? And how did slope come into play for us? Explain to me how slope was used on a distant time graph. Kobe. Pardon me? I just can't hear you. I don't know if you're right or not. I just can't hear you. Yeah? Yeah? Oh, yeah, there was that one. Yeah, that was the trig question. Good call. Yeah, that was certainly part of it. And you could have used the slope then. Good one. What else?
When you're trying to see if it's going faster, if it's like a race or something.
Yeah, how does that help? Why does slope work?
Because the one that's steeper is going faster.
The one that's steeper is going faster. Why? All you're doing is repeating stuff I say. Tell me why.
It has less time.
It has less time to cover
More distance.
more distance, right?
Yes.
So slope, not only is it a measure of steepness, it is also a measure of change, isn't it? Right? Okay, so now we're going to talk about it. We are going to start all of our graphs here, for examples, at the bottom. Right now. All right. If I am going to go from A to B on this slope, please describe how I would get there. What would I have to do? Michaela? I would have to go up on the y-axis, which on a graph is what? Positive or negative?
Positive.
Positive. Excellent. Positive y. Everyone agree? Then what?
We go positive x.
I would go to the right on the x-axis, which is what?
Positive.
Positive. Excellent. Now, if this were distance and time, that would get me distance, d, divided by time, t, wouldn't it? And that would get me a kilometer per hour. Agreed? But this is not distance divided by time, is it? What is this? This is not a d, it is a y, yes? It is. This is... Piss off. This is a change. That's a physics symbol for change. It's just a triangle. The change in y divided by the change in x. Now in this case, you can see that it is positive and positive. Yes? Everyone cool? Great. Now I'm at B and I want to go to A. How do I get there?
The opposite.
So tell me.
Negative y down.
I go down on the y, which is negative y, and then I go
To the left. Negative.
negative x. So what would this be? It's still delta y, change in y, divided by change in x, but they're both what now?
Negative.
Negative divided by a negative to get me what? A positive. So this slope is positive. Now Supreet has given us a little reminder here. It is rise divided by run. I don't like opening with that because for some strange reason, having two definitions in your head is too much for most of you at this point. So when I say rise and run, people, oh, which is which? I don't remember. So I don't talk about it for a while. But Supreet's let the cat out of the bag, and that's okay. We're going to talk about it right now. Is everybody cool with that? So right now, as of now, you have 1, 2, 3 definitions of slope. If you have 3 definitions that are all definitions of the same thing, what do you know about each of those definitions? What I mean is this. A equals B, D equals B, and F equals B. What do you know about A, D, and F?
They all equal B.
They all equal
B.
and?
And D. And A.
Yes. A also equals D, doesn't it?
Yes.
A also equals F, doesn't it? And D also equals F, doesn't it? So now you have 3 definitions for slope, which means you have 3 ways you can use slope. All of them are the same. So if your slope doesn't look like something you're used to seeing, you have 3 other ways you can calculate it. Does everyone understand? All right. So let's look at the next one. From A to B, how would I get there? Up, which is what?
Positive.
Positive y. Then what?
To the left.
Left, which is
Negative.
negative x. So I have a positive divided by a negative. So what kind of slope would I have? A negative slope. What if I go the other way? Down, which has a negative y. See how I craftily I have made these notes so my negative y works twice? And then what? Positive x, giving me a negative divided by a positive. Do I still have a negative slope? Yes. Does it matter where I start? No. Everybody good? Now, the 2 weird cases. What do I have there? How do I get from A to B? Positive y. Did I go anywhere sideways? So, is there any change in x? So, since slope is change in y divided by change in x, and there's no change in x, what number would go there? 0. Is that possible? Is division by 0 allowed in our number system? No. So this is what we call an undefined slope. Because anything divided by 0 doesn't exist. Cool? Alright. So now you guys are smart kids. What's happening here?
Plus positive x.
It's positive, oops. It's positive x. Is there any up and down? So what goes in for y? 0 over x. Is that allowed? I have no pizza. You want half of it?
Sure.
How much you getting?
No.
None. So is that allowed?
No. It's undefined.
No, it's not.
No.
I have no pizza. Do you want half of it?
I can't get half of it.
Yes, you can have half of it.
Oh, it's
Are you ready? There. How much pizza do you have?
none?
None. Does none exist as a number?
Yes, so.
You guess so? What number is nothing?
0.
So does none exist as a number?
Yes.
Okay, so is this allowed?
Yes.
Yes. So what is this slope? 0. This slope is undefined. This slope is 0. Do you understand the difference?
Yes.
Okay. Now, in here we are going to put all of our definitions of slope. The word slope is abbreviated, and I don't know why, as the letter M. Whenever you see the letter M, you have a slope. Always. Okay? Please notice these slopes are all how many values? Okay, I must have asked a bad question. On this graph, this point right here has how many values associated with it?
2.
2. What are they?
X and Y.
X and Y. So, this point right here has how many values associated with it? 2. What are they? X and Y. The slope has how many values associated with it? 1. What is that value? M. And we find M by going up and right, or down and left, and doing division. So there is only one value. Do you understand? I get a million. Down and left still gets you one value because you're dividing the down by the left, which gets you one answer. Is everyone okay with that? Every year I get people telling me the slope is 6, 2. Is that one value? No. So that's not a slope. Gerard? No. You could, but you would not, because that's a pain. All the lines are going to be straight. It's linear relations. Yo! Except, one sec. Pythagoras gets you a distance. Is slope a distance? Yes or no? No. Slope is a rate of change. Slope finds the speed on a distance time graph, not a distance. Who mired me over there? Supreet. Yes, we're getting to that. You keep letting the cat out of the bag slightly before I'm about to.
Why is there a cat in the bag?
Because we're not sure if it's alive or dead. We're all Schrodinger. That's why the saying exists. If you let the cat out of the bag, you know what is happening. When the cat is in the bag, you do not know if the cat is alive or dead. It's Schrodinger. And because you don't know the cat is alive or dead, it is simultaneously both at the same time.
Whoa.
Once you let the cat out of the bag, you then know. And that eliminates half of the world's realities. So, slope M always. And what do we know about slope? It is a value. It is not a distance. It is not coordinates on a graph. It is simply the ratio of change in y divided by change in x. That is all it is. Okay? Now, it's a million things though. Supreet gave us one. You can take the rise and and divide it by the run. Right? Which means you can go up on a graph and divide it by the, well, it should be up or down, and divide by the left to right. Okay? In physics, we write it as delta y over delta x. Delta is the Greek letter for change. Okay? So you can do it that way. On a graph, you can count up, down, and divide it by the count of left to right. That's for on a graph. And there's one other way you can do it. You can take the difference in y. So if you have two y values on a graph, you can find their difference by subtracting. And then you can find the difference in the x by subtracting. Okay? Now if all of these are slope, and slope is always m, are there other things that I can write in this equation instead of m? Yes. I could also write delta y over delta x, x plus b, right? I could also write rise over run, x plus b. I could also write y2 minus y1 over x2 minus x1, x plus b. Does everybody understand? Since all of these are slope, any one of them can go into the equation. And if the equation has our output isolated, it automatically gives us our slope. Is everyone okay with the theory? All right, let's see if you can put it into action. I have 4 functions here. Before we do any work with them, check. Is the output isolated? Yes or no? Yes, the output is isolated. So do we automatically know the slope and the y-intercept? Excellent, I do. I'm going to put a black dot on the y-intercept for A. What is it? -4. 1, 2, 3, 4. Does everyone agree? I'm going to shrink this down a little so you can see the function and the graph. Is everyone okay with that being the y-intercept?
Yep.
Just to prove it, on the y-intercept, x's value would be 0, wouldn't it? So that's going to drop out, and what's left? -4. Is everyone okay? Yeah? All right. Now, what do you know about that 2? It's the coefficient, which in this case makes it the slope, right? A slope has one value, but 2 components, doesn't it? What are the 2 components of slope? The change in x and the change in y, or the rise and the run, yes? So what is this 2 really over? What is every number in our number system really?
1.
If they're all over 1. So now do I have 2 components? Do I have a rise and a run? Is it positive? So from here, how do I rise +2? I go up 1, 2. But that's only one part of our slope, isn't it? Don't I also need a run? Of how much? 1. Positive or -1? So which way is that? Right. Does everyone see how it works? Could I also go down 1, 2, which is negative, and left 1? Yes. And there is my first line, which of course would carry on forever, yes? There is A. Everybody cool? Now watch. 1, 2, 3, 4. Negative 4, yes? 1, 2, negative 2. What is negative 4 divided by negative 2? Positive 2. So my slope is 2. Does everybody understand? Please notice, I didn't even use the y-intercept, but the slope stayed the same. Why? Supreme. I didn't do anything to the line. The line goes till infinity, yes? And to be a line, the up and the over must be the same forever, yes? What if I went up to 3 billion? I went up 3 billion. How far out here would I have gone? 1.5 billion. Got it? Okay. Let's put a blue dot on B's y-intercept. What is it? 1. Excellent. And what is the slope for B? 0? Hannah? Negative 1. Which means what is my rise? I drop 1 to get a negative, and then where do I go? Right to get my positive. Could I also go up 1 and left? Yes. And there is B. Everybody cool? And we check. Positive 2, negative 2. What's positive 2 divided by negative 2? What kind of 1? So that slope is negative 1. Everybody good?
Yeah.
Okay. What's different about C? Do I have a y-intercept? 5. 1, 2, 3, 4, 5. Green dot, yeah? What's different now?
There's a fraction.
Fraction should be easier, shouldn't it? Isn't every slope rise over run?
Yeah.
Okay. So?
We go up.
Okay. Noah wants to go up 1. That's a positive.
Down 1.
Okay, that's a negative.
Yes.
Then where?
Over 3.
Over means nothing to me.
Left 3.
Left 3?
I want to go left.
Go straight.
Alon, where do we need to go? Why? Because I need a positive and a negative.
Go.
1, 2, 3. Or
We all the way.
up 1 and
Left.
left 3. And again, positive 2, negative 6. Positive 2 divided by negative 6 is negative 1/3. Everybody getting this? And finally, we'll do a gray dot. That's a red dot, dummy head. A gray dot for this one. That's tricky. What's the y-intercept? 0, because it doesn't have 1. And what number doesn't have 1? Don't point at me, say a number. 0, because I have no pizza. So I have 0 pizzas. What's my slope? 1. So where do I go?
To the right.
Why, I should probably do my rises first, because it's rise over run. Up, how far?
1.
1, and right or left?
You have to do a negative.
Where do you see a negative in that equation?
You see a positive and a negative.
So I did up 1 and right 1, or down 1 and left 1. Correct? Could I go up 10 and right 10?
Right.
Could I go up 3/4 and right 3/4? Yes. Could I go up 3 billion and right 3 billion? Could I go down 7 and left 7? Is everybody understanding slope? Everyone is good? Okay. Let's see. Refer to the graph in number 1 and find the f of 2. So which of these uses the f of 2? A. So that for us is the black line, correct?
Yeah.
So the f of 2 means what? X is 2. So I go out to 2 and I find where the line is. The line doesn't get to there, does it? Except it does, doesn't it? Because how far does that line go?
Forever.
Forever. So I would go up 2 over 1. Oh, there it is. Does everyone see it? So that's how we find it on the graph. X equals 2. Y. Can we also find it algebraically? Yeah, we could, because it's the f of 2. And what was our function? 2 minus 4, yeah? Well, what's 2 times 2? Minus 4? 0. So we knew it algebraically was 0, and we knew it graphically was 0. Everybody good? Use both methods to find h of 3. Which of these is 3? C. The green line, yeah? And I need the h of 3. So, the h of 3 means x equals what? 3. So I go up to my graph, I go out to 1, 2, 3, and I find where the y value is. Oh, it's already there for me, isn't it? What is it? 4. 1, 2, 3, 4, correct? Now do that with algebra. The h of 3 is negative 1/3 times what? 3 plus 5. What's negative 1/3 times 3? Negative 1. What's negative 1 plus 5? 4. And we're good. Correct? What's different in C? Doesn't give me an x, but it gives me a y. So, algebraically speaking, what color are we doing for that one? That's B, yeah, the blue line. So our y is what now? 4. I need the x. So I go up to 4 on the y, 1, 2, 3, 4, and oh, there's no x yet. So what must I do to my line? The line has to continue, doesn't it? So you can see it's going up 1 over 1, up 1 over 1. Oh, there it is, isn't it? There's my 4, yeah? So when y, oh no, I didn't, that's 3. 1, 2, 3, 4. Oh no, it is 4. What's my x value?
3. Negative 3.
1, 2, 3. No, I did need to go one more. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. And my x value is? Negative 1, 2, 3. Now do it algebraically. My g of x is 4, yes? So it's 4 equals negative x plus 1, yeah? So solve it. Minus 1 from both sides, 3 equals negative x. I don't want negative x, I want positive x. So it's negative 3. Everybody good with that? And the last one, f of x is negative 1. So that's going to be the 2x minus 4, but I know the f of x, yeah? So do I know the y or the x? The y is what? Negative 1. So on my black line, I go to negative 1, and then what? I go over and I see, what do I see? We're not sure, are we? Can we be exactly sure what that fraction is from the graph? No, because this graph has not been scaled, has it? It's somewhere between 1 and 2. We don't know what it is, do we? So sometimes graphic use lets us down, doesn't it? So if graphing lets us down, what must we rely on? We think x is about a half, yeah? Oh, sorry, 1.5, right? So I'm going to change this because we're not totally sure to the approximate sign of 3 over 2, which is 1/2, yeah? 1.5, right? So since the graph has let us down, what must we go to? Algebra. So the f of x is negative 1. So I had negative 1 equals 2x plus 4, yeah? No, minus 4. Agreed? Solve. What do I do to get rid of plus 4?
Minus 4, plus 4.
Add 4 to both sides, so it's 3 equals 2x, divide by 2, x equals 3 halves. So we were absolutely right. Is everybody good?
Yeah.
Everybody's good? Yeah? Okay, so now you should be able to do 384, number 13, and 362. 4, 5, 7, and 17, I think it is, yeah?
Okay.
Let's do it, though.
Now, this one, you want to be using mx plus b. For number 13, when you look at it in your textbook, you will notice something. It's not written in this form. Right? So I want to remind you guys of something. If I have something like this, 3x plus y minus 16 equals 4. Can you take that and make it look like that?
Yeah.
Of course you can. Because this is y equals mx plus b, right? So what do you see that is different between these two? Do they have all the same components? Is there an x in both?
Yes.
Excellent. Does x have a coefficient in both? Excellent. Is there a y in both?
Yeah.
Yes. Is there a constant in both? So can you make this look like this? Yeah, because you've got all the pieces. This is Lego pieces on the floor. Build this. How? 3x plus y minus 16 equals 4. I need y by itself, yeah? Is y already by itself? Just that. Does y have a coefficient?
No.
Is y positive?
Yes.
Do I need y without a coefficient and positive? So y is okay as it is, right? Can x be over here with y? No, so what do we got to do with it? Move it. How do you move something in algebra? Opposite operation. This is a positive 3x. So how do I get rid of it? I subtract 3x. Where else? On the other side. So this guy's moving over here. What's going to happen to his sign? Minus 3x and a plus 4, correct? Everybody cool? What about this guy? Is he allowed to be there? Is he allowed to be there? Is the constant allowed to be over here with the y? Nope. So how do I get rid of it? He moves over here and becomes positive. So y equals negative 3x what is it?
20.
Plus 20. Everybody good?
Yeah.
Do looks matter?
No.
No, because you can always move equations around to what you want them to look like, can't you? We've been doing it since you guys, even though you don't know it, have been doing algebra since the 3rd grade. They just didn't call it algebra. In grade 3 it was, little Noah has 4 apples.
Yay.
Right? But the basket has 11 apples in it. How many apples did little Joel bring? 7. That's algebra. But nobody called it algebra then. They didn't start calling it algebra until grade 8 when you were scared of it. If they started calling it algebra in grade 3 when it was apples, then none of you would be scared of algebra. Nor would your parents have been scared of algebra. Because when you talk to people, they're always like, oh, I'm so bad at algebra. But then if I said, hey, I got 5 slices of pizza, I need 9 slices of pizza to feed my family, how many more pieces do I need?
4.
Everyone, well, you need 4 more. Duh. That's algebra. Because there was an unknown number in the middle there, wasn't there? And yet, people have the audacity to say they can't do algebra. Right?
Yeah.
I've got 17 slices of pizza, and I've got 5 kids. How many slices does each kid get? That's algebra. Don't do the math. I'm just telling you, you already know how to do algebra. Everybody good?
Yeah.
Okay. You've got not very much work to do for tomorrow, and you got a bit of time to do it right now.
Okay.
Send it, man.